All right, here we are on the last page of your Unit 1 review, and it's starting out with a given function. It wants you to determine, given this input, what is the output. So it's giving you f of 2. So notice into this equation, this original equation, I have input a 2 everywhere that there was an x. So this 2 is plugged in for x, this 2 got plugged in for x, and this 2 got plugged in for x. So here we go simplifying. So f of 2 equals, now we have to remember our PEMDAS here. Remember that you're going to always do the exponent before they multiply. So the 3 is going to stay alone for a sec, while the 2 squared becomes a 4. And then next 2 times 2 makes 4, and then it's plus 4 at the end. So the only thing I did in this step was the 2 squared, and then the next step was this multiply was able to happen. Right, so f of 2 equals 3 times 4 makes 12, plus 4 plus 4 is 8. Final answer, f of 2 equals 20. How'd you do? Now in this one over here, it's a little bit more complicated because instead of just plugging in a number 2, you're plugging in an a plus h, two different variables. So notice again that I plugged in for the a plus h right here, I plugged in for x, and then I plugged in an a plus h here for x, and then I plugged in the a plus h here for x. So you're putting in a plus h everywhere that there was an x. So this is going to be equal to 3 times the quantity. Now a plus h squared. I'm going to go off to the side here to do this one. A plus h times a plus h is really a times a times h times a, and h times h. And then I combine these middle terms here. How many total? I have 1, 2 ah's. So I have a squared plus 2 ah's plus h squared. Now, if you don't remember how to do this distributing process, just know that we are going to go into this in depth in Unit 3. So if you don't understand it now, there will be time to pick it up again in Unit 3. All right, so this becomes 3 all times this whole quantity, a squared plus 2ah plus h squared. Oh, that was a long one. All right, and then plus, now you're just going to distribute the 2 times the a and the 2 times the h. So plus 2a plus 2h plus 4 at the very, very end. All right, now we're going to do some distributing here in the front. We're going to get equals 3a squared plus 6ah plus 3h squared plus 2a plus 2h plus 4. Now we're looking, are there any like terms that we need to combine? Here's some a squareds, no other a squareds. Here's some ah's, no other ah's. H squareds, a's, h's, 4's, nope. So my final answer is done. F of a plus h equals all of that. And it's fully simplified because we cannot combine any like terms. And again, if that one feels like it's going to be the most difficult one for you on the test, remember that in Unit 3, we're going to go over how to do that first, outer, inner, last FOIL process or distribution process. For the next one, for the domain and range of each of the following functions, we want it in interval notation and words. Use the graphing program like Desmos to help you visualize the graph. So here I go with the first one, 1 over x plus 3. I'm going into desmos.com, graphing calculator function. And remember that we can type in the f of x equals, or you don't have to. So 1 over x plus 3, go back and double check it. 1 over x plus 3. Okay, so what is my domain? My domain goes all the way left, all the way up until right here. There's nothing going on here, up or down. That's going to later, we'll learn, be called a vertical asymptote. So nothing's happening here, but then it starts up again right after that and keeps going forever. So we can say that our domain goes from negative infinity until negative 3, and then from negative 3, not included, all the way to infinity. So let's go take a picture of this graph though, and put it on. Oh, that's right. In this, we have to save it as an image and insert the image. All right, so we're going to say that the domain goes from negative infinity to negative 3, and then from negative 3 to infinity. And then the interval notation of that, we're going to write it as negative infinity up to negative 3. Actually, I'm sorry, interval notation, excuse me, to negative 3. U for union, and then from negative 3 to infinity. Notice the open brackets on everything, showing that you cannot touch infinity, it's not included, showing that the negative 3 was not included. U for union. All right, second one is the graph of g of x is equal to x, square root of x plus 6. So let's go into Desmos and graph it. Square root of x plus 6. Here's my square root function. Let's go ahead and take a little image of it. Insert the image. All right, so this domain goes from negative 6 to infinity. And so we can say in interval notation from -6. This time it's included, oops, to infinity. So we're going to say infinity is always an open bracket. This -6 is included this time, so use that closed bracket. Now the range of this one goes from 0 and then up forever. So we'd say from 0 to infinity. And I just realized that over here I never did the range. So notice the range goes forever from the bottom up till 0, doesn't touch. Then it goes from 0 to infinity. So let's go over here and put in the range from -infinity to 0, and then from 0 to infinity. And so that range could be written as -infinity to 0, U for union, 0 to infinity. And just to show you that this is the range for this guy. Okay. All right, so over here on the last one, let's go graph this cubic function. It's got a power of 3, so it's cubed. So I'm going to go put this into Desmos, x to the third plus 2x plus 5. And here's my cubic function. Notice it goes forever up, forever down, forever left, and forever right. Even though it's going steeply, it is getting wider and wider as time goes on. So let's go take a little picture of this cubic function. So we can say that the domain goes from -infinity to infinity, and that the range likewise goes from -infinity to infinity. How we say that in words: domain is all real numbers, range is all real numbers. You can also say is the set of all real numbers, and those mean the same thing. All right, given a system of linear equations, draw a sketch of the two lines. So show me a sketch where there's only one solution. So drawing one line and another line where they touch once, that's one solution. Show where there's no solutions, one line, another line where they never touch, parallel lines that have the same slope, and infinite many solutions. So when you draw one line and the other line is exactly on top of it, so they're literally the same line, so they touch everywhere. Write the equation of the line that is parallel to this and passes through this point. So first of all, I need my slope from this equation. Parallel lines have the same slope, so m equals -4. So now I go write the equation using point slope form of y minus 11, use our slope of -4, x minus 6. So y minus y1 equals m, x minus x1. Done. Write the equation that is perpendicular to this. Remember that perpendicular slopes are negative reciprocals. So we're going to go ahead and flip it and make it a negative, which makes it -3/4. And that quick note that perpendicular lines have negative reciprocal slopes. So here I go writing the equation of my line using point slope form. Y minus a -5 equals -3/4 x minus 8. And because of this minus a negative, I am going to take one final step in simplifying. Y plus 5 equals -3/4 x minus 8. Final answer. Sketch a graph that is or that shows a linear that is decreasing, exponential growth, and exponential decay. All right, linear and decreasing would be any line that's going down. Exponential growth is any curve that's going up. Exponential decay is any curve that's going down. And that's it for our review.